Welcome my dear students. This is a new video in which I am going to explain how to run and interpret multiple linear regression model in R software. Kindly watch this video up to the end so that you could understand the whole process. Before I do anything, let me open my R Studio, and R Studio interface looks like this. There are three areas. That is the console area, and on the right there are two areas. The upper area is that of environment, history, connections, tutorial, and so on, and the area in the bottom on the right is specified for files, plots, packages, and other tabs. Let me first of all file, new file, R script. This will open text editor for me, and after this I'll import dataset that I'll use for my multiple linear regression model. To do that, I can import dataset by clicking on this, or I can do the same, that is to import dataset from file and go to this area. Since I know that my data is in CSV format, so I'll click on text reader. You can also import dataset from Excel format, from SPSS, from SAS, and from Stata. So my file is in this format. So here is, I'll browse this, and since my data file is on desktop, so I'll go to desktop, and here in desktop let me look for the file name. This is my file name, which is HSB2, that is household beyond survey. And in this data set there are 11 variables and there are 200 observations. After this I'll click on import. This imported my data set which is titled as HSB2, and it says there are 200 observations of 11 variables. These are the 11 variables. Some of the variables, that is female, race, socioeconomic status, school type, and program, they are qualitative variables. They have codes, and these variables from read, write up to social study, these are numeric variables or quantitative variables. These are scores of 200 students in this survey. So after that, but before I do anything, just for the sake of example, this is a hypothetical example. I'll use science as my response variable or as my dependent variable, and take math, read, and write as my independent variable. So in this example, in multiple linear regression model, science will be my dependent variable, math, read, and write, that will be my explanatory or predictor or independent variables. So I'll go to untitled here, and now I will start my process here. If you are for the first time here in this interface, you will have to install package, and the package name is LSSR. But if you have installed, for example, I have already installed it, so I don't need to reinstall it again. Instead, I'll ask library and LSSR, and I'm asking Stata to load this command for me, or this package for me. So it says this has been loaded. After this, I'll use this command regress, and since my dependent variable is science, so I will write the name of the response variable or the dependent variable followed by tilde, and after tilde I'll give the list of explanatory variables. So my first explanatory variable is math, my second explanatory variable is read, and my third explanatory variable is write, and after comma I'll write data is equal to HSB2. So R will use this file to run this regression of science on math, read and write score. So if I do that, okay, there is some mistake here in this. Okay, this should be regression. Instead of write regress, it should be regression. So you have to write the complete name of this command, regression. So since I used this regression command and then in my argument science followed by tilde, and after tilde there is math, read, write. These three are independent variables, and the data set that has been used here is HSB2, which is this data. Before I explain my output of this multiple linear regression model, let me explain the plot. Here in this plot there are plots of science against various independent variables. So this one is for science and math. So this plot shows basically that there is a positive correlation between mathematics score and science score, and you know this is the fit line, the regression line. So it says that both the variables are positively correlated. So the coefficient for the math variable will be positive, and the coefficient of correlation between science and math is 0.63, which is very high. Similarly, this is the graph of science and reading score. This is also positively sloped, and it says that both science and read, they vary in the same direction. That is, there is positive association or relationship between the two, and the correlation coefficient between reading score and science score is also equal to 0.63. And finally we have this graph, a plot of science and writing score. This is also positive. This also shows positive relationship between science and reading score. So these three graphs are of value to us because our dependent variable is science, and this is math, which is an independent variable, and this is reading score. With science, this is also independent variable, and this is writing score, and science, this is also independent variable. And the correlation coefficient between science and write is 0.57. This is the correlation coefficient between math and reading, and this is the correlation coefficient between math and write score, and this is the correlation coefficient between reading and writing score. So this is one graph, and after this I'll show you another graph. This graph shows basically observed residuals against fitted values of these residuals, and this one is the fitted line, and there is no much deviation between the fitted values of residuals and the actual or the observed residuals. So this is a good sign. And after this I'll show you the probability density function of the residuals, and here there are actual and the fitted residuals, and they are well behaved, and they are more or less like bell shape. So it implies that the residuals follows normality. So this is also a good sign. So these three graphs are of value here. And after this I would like to explain my regression results here. So okay, so I start with this. This is the background. So the data frame that has been used is HSB2. HSB2 means this is a household beyond survey, and there is data. My response variable or dependent variable is science. There are three explanatory variables: math, read and write. So these are all scores, and this is a hypothetical example, and I basically want to see whether there is any dependence of science score on math score, reading score and writing score of students. In this analysis, 200 observations have been used, because there are no missing values in this, so all the 200 observations have been used. After this is the basic analysis, and these are the estimated coefficients. This is the estimated coefficient for the intercept, and this is the intercept, this is the coefficient for the math score, this is the coefficient for reading score, and this is the coefficient for writing score. So this coefficient basically means that if math score, reading score, and writing score of the student is 0, then on the average the science score of that particular student is 8.407. But usually these scores are not 0, so we will put values of these independent variables in the regression equation, and then we can get the predicted score of science. These are the standard errors of these coefficients. These are the t values, these are the p values, and here we have the lower limit and the upper limit of 95% confidence interval. After this, okay, let me also explain this. What does it mean? This means that for a 1 unit increase in the math score of a student, there will be a corresponding 0.319 unit increase in the science score of the student, keeping reading and writing score constant or the same. Or you can say this is for 1 unit increase in the math score of a student, there will be a corresponding 0.319 unit increase in the science score, adjusting for read and math and writing score. After that, I'll see the model fit, and here in the model fit we see this is the standard deviation of residuals. Standard deviation of residuals is equal to root mean square error. Root mean square error is the name of the standard deviations of residuals in stata, whereas in R it is standard deviation of residuals. This is the R squared, which is equal to 0.5, and this means that 50% of the variation in science score is explained by these three independent variables, that is score in mathematics, score in reading, and score in writing. This is the adjusted R square, that is adjusted for degrees of freedom. This is unadjusted R square, that is unadjusted for degrees of freedom. This F stat, the value of which is equal to 65.319, this basically is testing the hypothesis of zero population slope coefficients. So the null hypothesis is that the coefficient for math, read, and write is 0, and its p value is 0.000. So it means that we reject a null hypothesis, and we conclude that the coefficients of math score, reading score, and writing score is not equal to 0. So it means that overall equation is significant. Here we see this is the analysis of variance. This is a sum of square, this is a reading sum of square, and this is a writing sum of square. And here you have you see this is the model sum of square, or you can say regression sum of square. We also call it expand sum of square, or expand sum of square, regression sum of square, or model sum of square. Here the second one, this value, this is known as unexplained sum of square or residual sum of square, and below here this is the total sum of square. So if you divide this value, that is 9752.66, by this value 19,507.5, then we get the R squared value. Similarly, if you divide this value 9754.84 divided by this value 19507.50, then we get 1 minus R square. Okay, and here we have the F value for the model. This is 65.319, and its p value is 0.00. So it means the overall equation is significant. The overall model is significant. So here we have the correlation matrix of this model. As I mentioned earlier in the graph, this is the correlation coefficient between science and math. This is the correlation coefficient between science and reading score. This is the correlation coefficient between science and writing score. And these are important for us. There are also some correlation coefficients for reading and math, for reading and writing, and so on. And after this, this is the multicollinearity test. Here is the tolerance, and here is the VIF. Since no variable has a VIF score more than 5, it is less than 5, so there is no problem of multicollinearity. Similarly, the tolerance is greater, it should not be less than 0.2, so there is no problem of multicollinearity in this model. These are the best subset regression models, and after this, these results shows the data, the fitted residual, studentized residual, drifts, Cook's distance, and so on. So you can see these are the ID values. This is the observed values of math score. This is the observed value of the writing score. These are the actual or the observed data on writing score, and this is the observed or actual data on science. So, and this is the observed data on science, that is the dependent variable, and this is the estimated or fitted or predicted values of the dependent variables or the response variable science. These are the residuals. The residuals is the difference between this, the science score, and its estimated, that is the observed and the estimated. So this is the observed score of the dependent variable, and this is the estimated score of the dependent variable, and the difference between the two is equal to this. This is a studentized residual, and these are two other statistics, Cook's distance. And after that, there is the prediction error, and so on. And we can also see distribution of residuals in plot 1, as I mentioned earlier, and then the residuals versus fitted value. So this is the distribution of the residuals, the actual, and this is the residuals, the actual residuals against the fitted values of the residuals, and this shows no problem. We can also do the same thing using another command, and the other command is I will create a model, and I call it multiple reg. So multiple reg means multiple. You can give it any name. You can give it multiple regression, you can give it name multiple reg, or you can give it ml.reg, or you can just give ml. And after that, I'll write the argument, and then I'll use this instead of regression, I'm using lm. And since I'm using this argument, so let me copy it from here up to this point, copy, and I'll paste it here. And if I paste it here, I'll run it. If I run it, so the model has been run, and you can see it here. Now I'll call the summary of this model, summary, and within the parentheses I'll use this name multiple reg. So okay, this is the name. So if I run this, it will also produce the same results. So okay, so it produced the same results that I just did before. So let me show it to you, the lm command results. This is the lm command that I just gave. This is the summary. So below this, the upper results are those results that I got by this function regression, and within parentheses this argument. Now I'm going to show the results of this multiple regression by the command lm. So again, these are exactly the same that I mentioned earlier, and these are the residuals. These are the residuals, but the only difference between the two methods is that lm regression just give you the residual statistics, the descriptive of the residuals, and then the estimated equation, and r squared, adjusted r square, and f stat. It doesn't give you the additional information that we saw in this command, that is regression, followed by science tilde and the independent variable list, comma dot data is equal hsv2. So I recommend to use this because it gives you all these plots. This command doesn't give you these plots. These are the plots that we did with this function. I hope this was quite helpful, my dear students, colleagues, and friends. Kindly share this video with your students, with your colleagues in various WhatsApp groups. If you haven't yet subscribed to the channel, kindly do subscribe, and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll upload.